In this video, we want to talk about how to calculate simple moving average, or so-called SMA, in Python programming language using the NumPy package. So please stay tuned. So as you can see, I have defined a variable called x, which there are a bunch of numbers in it. And for example, suppose that I want to calculate the 3-step simple moving average. And maybe you ask, what do I mean by 3-step and what do I mean by moving average? And I will explain. And now here's a question. What do I mean by 3-step simple moving average? When I say 3-step simple moving average, it means that every time I want to calculate the mean, or let's say the average of every 3 numbers. For example, here I want to calculate the average of these 3 numbers. Then I want to calculate the average of these 3 numbers. Then I want to calculate the average of these 3 numbers, and etc. So that's it. So here's the philosophy of 3-step simple moving average, because we are using a 3-step, we are using 3 data, so it is called 3-step. And also maybe you ask, why do we call it simple moving average? Because we are moving and we are calculating the average of these 3 numbers, then we are moving and calculating the average of these 3 numbers, then we are moving and calculating the average of these 3 numbers, and etc. And the next question is, why do we call it simple moving average? Because we are calculating a simple average. What do I mean by simple average? I mean just summing the values and dividing by the numbers. So the weight, let's say, in calculating the average is the same. So you can see that this value has the same weight as this value in the calculating the means. So this is called simple moving average, not weighted moving average. So let's see the whole process of calculating, for example, let's say 3-step simple moving average. So this is our data and we want to calculate 3-step simple moving average. So we are going to calculate the average of these 3 numbers. So calculating the average of these 3 numbers is equivalent to multiplying each number by 1 divided by 3, and multiplying this number by 1 divided by 3, and also multiplying this number by 1 divided by 3, which leads to these numbers. And if we add up these 2 numbers, we will get 33 divided by 3, which is equal to 11, which is the average of these numbers. So we append that to a list, and this list represents the simple moving average in each iteration. This is iteration number 1. And now let's go to the next iteration. Let's move this to the right. So we are going to calculate the simple moving average of these data, which is 28 divided by 3. So we append that to the list. And this is another iteration, and this is the summation of these values, 21 divided by 3. So we append that to the list, and etc. So you can see that here's the list that represents the simple moving average in different iterations. And if you calculate all these numbers, you can see 33 divided by 3 is equal to 11, 28 divided by 3 is 9.3, 21 divided by 3 is 7, 12 divided by 3 is 4, and 8 divided by 3 is 2.6. So this is the result of 3-step simple moving average. And this process of calculating this simple moving average is exactly the same as calculating something called convolve operator. And what do I mean by convolve operator? You should wait a minute because I'm going to explain it. So here we have a vector, vector1, which is a red vector. And also we have a black vector, and we want to convolve these together. The general idea of the convolve operator in this example, which is a one-dimensional and discrete convolve operator, so in this example the general idea is sliding this vector from left to right and multiplying each values. And maybe you ask, what is the meaning? Again, you should wait a minute, because after the example you will find out the meaning. So let's start. And as you can see, there is no values in these places, so we cannot multiply 1 divided by 3 by this value and 1 divided by 3 by this value, because there is no value. But here we have a value, so we multiply 10 by 1 divided by 3, which leads to 10 divided by 3. And let's write it beside the page. As you can see, 10 divided by 3. And also let's append that to a list. This list is going to represent the values of different steps. This is step number 1, and the value is 10 divided by 3. So let's go to the next step, which we are going to slide this vector to the right. We are going to slide this vector 1 block to the right. And now in this step, as you can see, we don't have such value here, but we have values here. So 10 times 1 divided by 3 is 10 divided by 3, and also 11 times 1 divided by 3 is 11 divided by 3. And if you sum these values, you will get 21 divided by 3, and you append that to the list. So this is the value for the first step, and this is the value for the current step, which is step number 2. And now let's again slide this vector to the right, one block to the right. As you can see, here we can multiply each values. So 10 divided by 3, 11 divided by 3, 12 divided by 3. And if you sum these values, you will get 33 divided by 3, and we append that to that list. And again, let's slide it to the right again. So now we are going to multiply it, 11 divided by 3, 12 divided by 3, 5 divided by 3, and if you sum these values, you will get 28 divided by 3, and we are going to append that to the list. And again, we are going to slide this vector to the right, so we are going to multiply values, and this is the summation of these values, and we are going to append that to the list. And also, again, we are going to do the same for the rest. So as you can see, this is the final result of sliding that red vector and multiplying values. And if you do the calculations, this is the final result. 10 divided by 3 is equal to 3.3. 21 divided by 3 equals to 7. 33 divided by 3 is 11, and etc. So this is the convolve operator. And remember that the convolve operator has different modes. And the thing that we have talked so far is the full mode. I mean, we are calculating all the possible cases. So we are sliding this vector to the right, and we are calculating all the possible cases. But there is another mode called valid, which, for example, this case is not valid for this mode. Why? Because in this case, we don't have such values. Of course, in the full mode, there is no problem and you can do the calculations. But in the valid mode, this case is not allowed because you don't have two values in order to multiply. So remember that this case is allowed in the full mode, but not in the valid mode. In the valid mode, it is going to start from this case, which you can see, you can multiply all the values together. So in the valid mode, you're going to start from this case and you're going to multiply these two values, and then you're going to slide to the right, slide to the right, slide to the right, and slide to the right. And this is the final case which you are allowed in the valid mode. You cannot shift anymore because that is not going to be valid. And if you do the calculations, you will get these values for sliding the red vector to the right. And as you can see, the calculation of simple moving average is exactly the same as the convolve operator between these two vectors with the valid mode. And now let's calculate all this stuff in Python programming language using the NumPy package. So we define a variable called w, which is the weight vector, and because you want to calculate the 3-step simple moving average, we're going to simply type 1 divided by 3, 1 divided by 3, and 1 divided by 3. And so this is 3-step simple moving average. So this is for 3-step simple moving average. But if we want to calculate, for example, the 4-step simple moving average, then we are going to simply type 1 divided by 4, and 1 divided by 4, and 1 divided by 4, and 1 divided by 4. And for example, if you want to calculate the 2-step simple moving average, you should simply type 1 divided by 2 and 1 divided by 2. But now we want to calculate the 3-step simple moving average, so I deleted these lines, and as you can see, here is our weight, and this is our vector, this is our data, and we want to convolve these two vectors. So simply we can type np.convolve because we want to convolve these two vectors, and the first vector is w and the other one is x, and the mode is going to be valid. And then we store the results in a variable, let's say called results, and finally I print the results variable. So if I run a code, you can see here is the result of simple moving average with 3-step. And now we want to define a function in order to do all this stuff, for example, in a function called SMA, or simple moving average. But before going further, let's talk about a function called repeat in the NumPy package. So we simply type np.repeat. And first of all, you should say that which value you want to repeat. For example, I want to repeat 1. How many times? For example, 3 times. I mean, this is the repetitions. I want to repeat 1 3 times. And for example, let's store that in a variable, let's say called w, and let's cut these lines, and for example I want to print w. So if I run the code, you can see now we have 3 1, and if we divide this vector, if you divide this array by 3, you can see that it is 1 divided by 3, 1 divided by 3, and 1 divided by 3. So this is the step. And for example, if you want to have, for example, 4-step simple moving average, you should simply type repeat 1 and 4 divide by 4. And if you run the code, you can see you have 1 divided by 4, 1 divided by 4, 1 divided by 4, and 1 divided by 4. So this is how we generate our W, our weight array, our weight vector. So now we want to define a function, and let's name it, for example, SMA, simple moving average. And it takes the step as the argument, as the parameter, as the input parameter. And first of all, it's going to generate the weight vector, the weight array. So we simply type W is equal to np.repeat. You want to repeat 1. How many times? A step, number of times. And then we are going to divide that by a step. So this is the weight array. This is the weight vector. And also this function beside the step is going to take the data as the input to the function, and then finally we are going to convolve the the weight vector and the data, and the mode is going to be valid mode, and then we are going to store the results in a variable, let's say for example result, and now finally we are going to return the result variable. So now this is our x variable, which is our data, and we want to calculate the simple moving average for this data, which is our x, and the step, for example, is going to be 3. And we want to print all this stuff, so we want to print the results, and if I run the code, you can see here is the result. And for example, if you want to calculate 2-step simple moving average, this is the result. And for example, if you want to calculate the 4-step simple moving average, you can see here is the result.